What's up, guys? So today we're going to talk about collagen. It's the most abundant protein in the body, so we need to know pretty much everything about collagen, including how it's made, what it's for, like all the disease correlates from it and all. So let's start. It's very simple, not too bad. So we're going to say this is a cell. This is the nucleus of the cell, and from the nucleus we're going to get the mRNA transcript that's gonna be like encoding for the collagen protein and all. So this mRNA is gonna come outside, and there will be the rough endoplasmic reticulum here. And over here, what's gonna happen is that this, let's say, is the mature mRNA with the 5' cap and the poly A tail. And over here, there's a signal recognition peptide, which will get recognized and get pulled into the RER. Now, in the RER, this is going to get translated first into pre-alpha collagen. This pre-alpha collagen is a long chain of mostly prolines and lysine, so every third is pretty much a proline. You get what I mean? So, yeah. So proline is going to be the most abundant, and what's going to happen in the RER is that this is going to get hydroxylated. Like these lysines and these prolines will become hydroxylysine and hydroxyproline. And over here, this is going to happen with vitamin C. All right, that's why vitamin C is important in collagen synthesis. Now, what's going to happen is that this pre-alpha collagen, once it gets hydroxylated, it is going to start coming together into threes. Like, let's say this is one pre-alpha collagen chain that got hydroxylated. Then this is another pre-alpha collagen chain that got hydroxylated. They're going to form these three strands. And they're going to start getting cross-linked. This, when it gets cross-linked, this would be known as pro-collagen now. Pro-collagen. All right. Now what happens is that this pro-collagen ends up getting exocytosed, so now it's outside of the cell, with the NC terminal still on it. All right, so we're saying that this pro-collagen came outside and it has this NC terminal on it. Once this NC terminal gets cleaved outside of the cell, this will now be known as tropocollagen. All right. Then this tropocollagen will become collagen fibrils. These fibrils will then come together again. So like this is one, and then this will come together again. Collagen fibrils, and there will be cross-linking once more here. This cross-linking will be with the enzyme lysyl oxidase. This lysyl oxidase requires copper. All right. Then, once this cross-linking is done of the collagen fibrils, this will now become a strand of collagen. So if we think about it, this strand of collagen is actually cross-linked tropocollagen, which in itself, each strand is cross-linked pre-alpha collagen. All right, so that's the main pattern that we need to follow. What we can do to simplify it more is we can just do location and what's present there. All right. Now, in the nucleus, we would have the mRNA. once we get to the RER, we have the pre-alpha collagen plus somewhat of the pro-collagen. And then when we get exocytosed, this pro-collagen will get exocytosed. And now we would have tropocollagen. All right. And the pattern just goes along. Collagen fibrils and collagen. Nice. Lastly, we can just add in our disease correlates. So vitamin C deficiency, say scurvy. If there is a copper deficiency, which we see in Menkes disease, which is a deficiency of ATP7A flippase, which is required for copper absorption. So if there's no flippase, there's no copper, there's no cross-linking, so this person will present to us with brittle skin, kinky hair, growth and developmental delays, hypotonia. That's about it. All right, so we can do skin, dry, brittle nails, growth delay. All right, this is not to be confused with Wilson's disease, which is ATP7B mutation, and that's actually an increase in copper, not a decrease in copper. So here's the fun part over here. We have two of these. We have Ehlers-Danlos syndrome and osteogenesis imperfecta, which are very, very huge concepts. So what they like testing about them is that this pro-collagen is considered to be the defect in osteogenesis imperfecta. All right. And this tropocollagen is considered to be the defect in Ehlers-Danlos syndrome. All right, now let's talk about osteogenesis imperfecta. It's just a type 1 collagen mutation. All right, and Ehlers-Danlos, there's an E, so that's how I just like to remember type 3 E3, type 3 collagen, also type 5, but 4 right now, type 3. Yeah, that's osteogenesis imperfecta. And in the next video, we can do some like how to differentiate EDS and osteogenesis imperfecta. Thank you.